Hello, this is student for class 12, electric physics. This is electric current in conductors, Kirchhoff's law. I'm going to deal with it. I'm going to solve some problem, and when I'm going to solve this problem, you will see it becomes very easy for you to solve any type of electrical circuits. The first question is here, each of the resistors, each of the resistors in the given figure has a resistance of 10 ohm, and each of the batteries has an EMF of 10 volt. Find the currents through the resistors A and B in the two circuits. Here you see the circuit. It is given. This is the circuit. This is your circuit. Each of these are of 10 volts. Each of these are 10 volts and has a resistance of 10 ohms. This is 10 ohms and this is also 10 ohms. Now we have to find, this is A and this is B. We have to find the currents through these resistors A and B. So first of all, I am going to name these points as A, B, C, D, E and F. So by applying Kirchhoff's law, so how I will find the direction of the current? What I do, I first of all go to the junction points. This is the junction point. So here junction point, according to Kirchhoff's law, total number of in and out is the same. So I go to the junction point. So by taking this junction point, it becomes very easy for me to show the flow of the current. So see, current from this battery, current is flowing in that direction and this direction. So total input is equal to total output according to Kirchhoff's law. So now you see this circuit is completed, and again you see this, it comes here, and now this, see, your circuit is completed. The flow of the current is like this. In this circuit, this flow of the current is like this, and in this circuit the flow of the current is like this. So in which direction the current will flow, in order to determine it, I take the help of the junction points. If you take the help of junction points, it becomes very easy for you. Now I am going to show the flow of the current in these two loops. First, that is in loop that is A, B, F, A. So here you see VA minus VB, that is equal to, since the current is flowing from negative to positive side, so it will be minus 10 volt. And again you see VB minus VF, this will be equal to, let me take like this, that current I1 is flowing to this and I2 is flowing to this battery. So now here the current flowing is I1 plus I2, and again here it gets, I1 goes this side and I2 goes this side. So I1 comes out from this and I1 is entering into this. Here I2 is coming from this and I2 is entering the cell in the battery. So now, so here this will be 10 I1 plus I2, 10 I1 plus I2. And so according to the Kirchhoff's law, your total will be 0. So 10 I1 plus I2 minus 10 is equal to 0. So 10 I1 plus 10 I2, or I can say instead of this, let me do like this, 10 common, so I1 plus I2 minus 1 is equal to 0. So here I1 plus I2 is equal to 1. So in A, 1 ampere current is flowing through this A. Through A resistor, 1 ampere current is flowing through this. Now I am going to the loop, the second loop, that is in loop B, C, D, E, F, B. In this loop, here you see VC minus VB, that is equal to minus 10, and now VB minus VB minus VF, this will be 10 I1 plus I2, and now here again uh, VE minus VD, this will be how much? 10 I2. So again your total will be 0. So this will be minus 10 plus 10 I1 plus I2 plus 10 I2 will be 0. So here you see that your I1 plus I2 is 1 ampere. So minus 10 plus this is 10 plus 10 I2 will be 0. This is 0. So 10 I2 will be 0. So I2 will be 0. In B, the current will be 0, and in A, the current will be 1 ampere. This is in resistor A, and this is in resistor B. So if you take the junction points, it will be very easy for you to show the flow of the current. So this is your answer. Electric current in a conductor, Kirchhoff's law. See here, this is the circuit, and we have to find out the current in each resistor. So we have to find out the current in each resistors. We have to find out each resistors. We have to find out the current. So here I have taken this junction point and applying the Kirchhoff's law. See, total in is equal to total out. So here you see current flowing from this, and out is this. I have taken this 3 volt, so this direction and this direction, and this is the out. Now I am going to consider the loop CGHDC. In this loop you see VG minus Vn, that is equal to 1 into I plus I1. Now Vn minus Vh from higher to lower, so this is 2 volt, and Vd minus Vm from lower to higher, so this is minus 3 volt, and Vm minus Vc, that is equal to 1 into I. So total potential is 0. So I plus I1 plus 2 minus 3 plus I is equal to 0. So this is 2I plus I1 minus 1 equal to 0. This is equation 1. Now I am going to take this loop, that is loop GFEHG. Here you see again Vg minus Vn, this is equal to I plus I1 into 1, and Vn minus Vh, that is equal to higher to lower 2, and Ve minus V naught from lower to higher, so this is minus, and V naught minus Vf, this is equal to 1 into I1. So again the total potential is drop is 0. total potential drop is 0. So I plus I1 plus 2 minus 1 plus I1 is equal to 0. So here I plus 2I1 plus 1 equal to 0. This is equation 2. And now I am going to solve these two equations. 2I plus I1 minus 1 equal to 0. I plus 2I1 plus 1 equal to 0. Here into 1 into 2. So 2I plus I1 minus 1 equal to 0. 2I plus 4I1 plus 2 equal to 0. So this is equation 3 and this is equation 4. Your 3 minus 4, 3 minus 4, this is minus minus minus, so this cancels out. So minus 3I1 minus 3 equal to 0. So I1 is equal to minus 1 ampere. Now I am going to select any one of this equation. From equation 2 we get this is I minus I1 is minus 2 plus 1 equal to 0. So I minus 1 equal to 0. So I is equal to 1 ampere. And here again I plus I1, that is I is your 1 minus 1, that is equal to 1 minus 1, that is equal to 0. So here you see I1, the current flowing in I is 1 ampere, and in I1 it is minus 1 ampere, and in this it is 0 ampere. So this is how we calculate applying Kirchhoff's law. I always take the help of the junction point, and the junction point, and you see the I take the help of the junction point, and then I see the help of this the higher voltage. So this is the higher voltage. I consider it as if consider it that the current flow from this direction, and total current in is equal to total current out. By the help of the Kirchhoff's law, you can calculate this. Again, see, this is another question on Kirchhoff's law. Here again I have to find the current through 10 ohms resistor. What I do, I see, I take the junction point here. See, this current enters in, this current enters here, and this is out. So what I actually do is always I make the loops, the current flow in one direction. I always try to make the flow of the current in one direction. See, in one direction I always try to do this. So now then it becomes easier for you to calculate it. Now let me take loop that is A D C B A. So here you see this point B M, and so here you see again VD minus VC, that is equal to I current is entering to this and I1 this. So I plus I1 is coming out from D point, from the junction D. So VD minus VC, that is 6 into I plus I1, and again here you see VB minus VM here from lower to higher. So this is minus 3 VM minus VA. Again here you see this is equal to 10 into I1. So 10 into I1. Here you see. So here in this loop you see that here you see VD minus VC, that is this, and VB minus VM, that is minus 3 from lower to higher, and again here VM minus VA, this is this. I always try to make the current flow in one direction in a loop. Then it becomes easier for you to calculate it. So according to Kirchhoff's law, this in this loop the total potential will be 0, potential drop will be 0. So this becomes 6. So this is 6 I plus I1 minus 3 plus 10 I1 is equal to 0. 6i plus 6i1 minus 3 plus 10i1 equal to 0. So this comes out to be 16i1 plus 6i minus 3 equal to 0. This is equation 1. Now loop E, F, G, C, E, this loop. Here again you see current is flowing in this direction like this. So VE minus VD, this will be I into 3, and VD minus VC, this will be 6 into I plus I1, and now again VG minus VF, lower to higher, so this will be minus 4.5. Now 3i plus 6i plus 6i1 minus 4.5 equal to 0. So 9i plus 6i1 minus 4.5 equal to 0. This is equation 2. Now from 1 and 2, 6i plus 16i1 minus 3 equal to 0, and 9i plus 6i1 minus 4.5 equal to 0. So here 6 and 9. So to eliminate this, I am going to multiply this by 6 3s are 18, 9 2s are 18. So 3 6 are 18, 18i minus 48i1, 48i1 minus 9 equal to 0, 18i plus 12i1 minus 10, 8 1 9 is equal to 0. So minus plus, so here this will be minus how much, 0 5 1 60, 60i1 plus 0 is equal to 0. So minus 60i1 is equal to 0. So i1 will be equal to 0. So the current flowing through 10 amperes resistance is 0. Here flowing is 0. So this is how I calculate this is your answer. Current flowing through 10 ohms resistor is 0 by applying Kirchhoff's law. See, I always take the help of the junction point, and at the same time I keep in view that the flow of the current in each loop must be in one direction. Then it becomes easier for you to calculate the problem. Now you see this circuit. We have to find out the current flowing in each resistors. So what I actually do, you see here, I take a junction point. This is the junction point. So 2 in and this is the out. And in each loop, see, I try to make the flow of the current in one direction. See, one direction. In each loop, see, in each loop you will see the current flow in one direction. In each loop you see the current flow in one direction. Then it becomes easier for you to calculate it. Since all these are 2 volts, so I have taken the current flowing through each battery is I current is flowing through it. So here I have completed the circuit, the flow of the current, and now you can see in each loop the flow of the current is in one direction. In each loop you see the flow of the current is in one direction. In each loop the flow of the current is in one direction. So let us consider the loop A, B, G, H, A. Here you find that now you see VA minus VB, that is from higher to lower, so this is 2 volt, and VB minus VG, that is 2I into 1, and VG minus VH from lower to higher, so this is minus 2 volt. So in this loop your total potential will be 0. So 2I plus 2V minus 2V is equal to 0. So 2I is equal to 0. So I will be equal to 0. So here you see here the current flowing 2I, 2I, it is equal to 0. Here you can see the current flowing through this is 0, and in each resistor the current flow is 0. So in each resistor the current flow is 0. You can do this same problem by taking I have taken I because here you see all these are of same potentials. EMF of the battery are the same, so I current is flowing through each battery. So I have taken I here. You can also consider I1 and I2, but you will get the same result. I will show you one in one loop. Say here you take this is your circuit, and uh, let's say this is your circuit. Now if you take 2 volt, 2 volt, 2 volt, this and this, you take I1 current here, I2 current here, so this will be I1 plus I2, and again here this will be I1, and this will be I2 current will flow, I1 current and I2 current will flow here, and again here this will be I2 current will be flowing here, and from here you can take this I3 current, so this will be I3 plus I2, and here again you get I2 current and this is I3 current, and flow of the current is like this. So you can do the problem like this also. If you want, you will get the same result: B, C, D, E, F, G, H. You see in the loop A, B, G, H, you see that here you VB minus VA minus VB, it will come out to be higher to lower minus 2 volt, and VB minus VG, this is all these are 1 ohms resistance, 1 ohm resistance. So 1 into I1 plus I2, and then VG minus VH, this will be from lower to higher, this is also 2 volt, 2 volt. These are all batteries, 2 volt. So you see here lower to higher. So this is higher to lower, this is positive, and lower to higher, this is negative. So here again, what do you get? I1 plus I2, this plus 2 minus 2 equal to 0. So I1 plus I2 equal to 0. See, current in this loop is in this resistor is 0. And if you consider this loop again, you will get the same result. You can take loop B, B, C, F, G, B. Here again you see V, C minus VB, that is from lower to higher. So this is equal to minus 2V, and again from here VB minus VG, this is equal to 1 into I1 plus I2, and then here again VG minus VF, here you see from higher to lower, so this will be plus 2V, and again from VF to VC, VF to VC, VF to minus VC, this will be I3 plus I2 into 1. So here again you see one thing, that is I1 plus I2 minus 2 plus 2 plus again I3 plus I2, this will be 0. So this will be 0. So here you get I1 plus 2I2 plus this I3 is equal to 0. Again, since you have got I1 plus I2 0, so here I2 plus I3 will be equal to 0. So here you can see I2 plus I3, the flow of the current is 0. And similarly, if you go to this loop, you go to loop C, C, D, E, F, C. Here again you see VC minus VD from higher to lower, that is 2 volt, and VD minus VE, that is I3 current is flowing through this. I3 current is flowing through this, so this will be 1 into I3, and again VE minus VF, you see lower to higher, so minus 2 volt. So again here I have come from VC VD, then VD VE, VE VF, VF minus VC. This will be how much? I1 into I3 plus I2. So again your all this will be 0. So you get 2V plus I3 minus 2V plus I3 plus I2 is equal to 0. Here you see I2 plus I3 is 0. So this is 0. This is also 0. So again I3 is equal to 0. In this loop also the current is 0. You can solve it in this way or you can solve it in this way. In every case you will find that the flow of the current in this loop is 0. So you can calculate it this. The only thing I keep in mind that I take the junction and keep the flow of the current in one direction in every loop. In one direction, see, in one direction in every loop, in one direction in every loop. Now see, in this circuit you have to find the current in the circuit. So this is the circuit you have seen, and the flow of the current is, I have done it like this. Now your VB minus VA, that is equal to 10 into I, and VC minus VB, that is equal to minus 12 volt because lower to higher. VD minus VC, that is 5 into I, and VE minus VD, that is equal to from from lower to higher, so this is minus 6 volt. Now your total potential drop in this loop will be 10I minus 12 plus 5I minus 6 equal to 0. So this comes out to be 15I minus 6, 7, 8, 18 is equal to 0. So 15I is equal to 18. So I will be 18 by 15. So I is equal to 1.2 ampere. This is your answer. Now this is the circuit diagram. It is given to you. We have to find the current in 20 ohms resistors. Again you see that's how I take this junction, flow of the current, see, in this loop in one direction, again in this loop in the same direction. I1 current is coming from here, I2 from here, and I1 plus I2 it is entering here. So I1 this side and I2 this side. Now you will consider the loop A, B, E, F, A. Here again V A minus VB, that is equal to 10 I1, and VB minus VE, that is equal to 20 I1 plus I2, and VF minus VA, that is equal to minus 5. So again from the loop theory, that is 10 I1 plus 20 I1 plus 20 I2 minus 5 is equal to 0. So this comes out to be 30 I1 plus 20 I2 minus 5 equal to 0. Yeah, this is, you can take 5 common, or this is equation 1. Now again we take this loop B, C, D, E, B. Here again you see VC minus VB, that is equal to 10 I2, and VB minus VE, that is equal to 20 bracket I1 plus I2, and VD V now VD minus VC, that is lower to higher, so this is minus 5 volt. Again, from the loop theory, 10I2 plus 20I1 plus 20I2 minus 5 is equal to 0, so this comes out to be 30I2 plus 20I1 minus 5 equal to 0. This is equation 2. Now I am going to solve these two equations. If you solve these two equations, that is here you see first equation, 30I1 plus 20I2 minus 5 equal to 0, and the second is 20I1 plus 30I2 minus 5 equal to 0, here into 2 into 3, so this comes out to be how much? To 60I1 plus 40I2 minus 10 equal to 0. This is 60I1 plus 90I2 minus 3 5s are 15. 15, this is equal to 0. If you subtract this, minus minus plus, so this comes out to be how much? This comes out to be minus 50 I2 and plus 5 equal to 0. So I2, it comes out to be 5 by 10, that is equal to 1 by 10, that is equal to 0.1 ampere. Now I am going to put the value of in any of this equation. So from equation 1, it is 30I1 plus 20I2 minus 5 equal to 0. So this is I2 value is 1 by 10, so this will be equal to 2. So 30I1, 2 minus 5, this will be equal to minus 3 equal to 0. So I1 will be again 1 by 10, that is equal to 0.1 ampere. So current flowing through 20 amperes, current flowing through 20 ohms resistance, this will be I1 plus I2, that is equal to 0.1 plus 0.1, that is 0.2 ampere. This is the answer.